Hello students. In this video, we are going to learn about non-iterative fuzzy sets. Okay. So what are non-iterative fuzzy sets? So we have seen membership functions, types of membership functions, and what is a fuzzy set. Now coming to the non-iterative fuzzy sets. So these are the fuzzy sets where we will determine the required membership values without any iteration or without any optimization. So by the name itself, what is meant by iterative? You will do the same thing a number of times. Like how if for the optimization purpose, you may change the values and do the same thing multiple times. So the fuzzy set which are not required any iteration are called as non-iterative fuzzy sets. So in this degree of membership values can be easily calculated without any iterations. Now, the example for non-iterative fuzzy sets are triangular. So in the triangular fuzzy set, we have seen triangular membership function. So we'll have three parameters. One is A, one is B, and one is C. So if you see here, leftmost will be the A value, rightmost will be the C value, and peak will be the center. Then what we are going to do, we'll start from A, it will be 0, peak will be 1, and peak will be 1, and again C will be the 0. So the membership function assigns the values between 0 and 1. Okay. So it will not go for the more than that value. So example here, if you take the height representation like tall people. So tall people will have the degree of membership function as 1. Okay, then average height and lower degree will have the shorter than taller individuals. So if you make the people to stand in a line, so who will be the peak one, taller one. So this will be the best example for your triangular fuzzy sets. So what I'll do, I'll call everyone, I'll ask them to stand. If they stand, who will be the tallest one? The tallest one will have the highest membership value. So like that will come down according to their membership height of that particular person. Next one is trapezoidal function. We have seen that we'll have the four parameters A, B, C, D. Okay, we have seen in the trapezoidal shape membership value there. So the degree of the membership will be assigned between same 0 and 1 as the shape of the trapezoid. So in the triangular will based on the triangle, trapezoidal will based on the trapezoid. Now example will be if you take the representation of moderately warm. Okay, so we'll have the values like warm, like low warm, high warm. So if I take for the moderately warm, where the membership assigns high degrees of membership to temperature around the midpoint and low degrees for the membership value further from the midpoint. So if you draw that one, where you'll get the moderate warm, that particular value will take. For example, suppose if you draw the graph, see the trapezoidal will be like this, right? So this will be, I'll take consider as moderately warm. And you can take any other values like low, moderate or high degrees, this one. So the midpoint will comes under your trapezoidal tip. Okay. Now next one is the Gaussian. I think we missed this one. So Gaussian, we have seen the two parameters, mean and standard deviation. So it will be defined with the help of these two values, mu and this one standard deviation. And the degree of the membership will also according to the distance from the mean, which are the elements closer to the higher mean values. Okay. So for example, we'll take the blood pressure. In the blood pressure, we are going to calculate the normal blood pressure, where membership function assigns high degree of membership to the blood pressure readings around the average and lower degree for the readings for the average. So what is the meaning of this? 1 second. Okay. So if I take the blood pressure as a parameter, so you'll have the normal one. So normal will have the high value. So suppose if I take 120 thing. So normal blood pressure, this will have the peak value, that is 1. So whatever the values you are getting beyond that or less than this will comes under lower degree of the membership. because my blood pressure will be normal if the value is only 120. Otherwise, it is abnormal, right? So if it is high, again we go for the different options. If it is low, again we go for the different options. So this is example. Now, next one is singleton. So we have seen any set which is having only one core value, then it is a singleton set. So example will be representing the temperature which is exactly 25 degrees. Okay, for this I want to give one example. 1 second. Yeah. Suppose if I have a set called like this. So I have the membership value. I'm not writing the x values. One is 0.2, comma. So another is 0.3. So one more is 0.1, no 0.1. Okay. So what is this set called singleton? Why? Because I have only one core value. If I have one more core value, then it is not singleton. So what is the meaning of this? I'll ask the question like, out of all the temperature, which one is having exactly 25 degrees? If it is 26 also, it will not give 1. If it is 24 also, it will not give 1. So only if I have only 125 degrees, then only it will be singleton. See, remember 25 should not be repeated. Okay. If 25 is again repeated, I'll get one more 1. So then it is not a singleton. So what is the meaning of singleton? For just to check whether this particular singleton is available or not. Okay, done. So what we have done, what are the iterative, non-iterative fuzzy sets. So thank you.